Welcome to the easiest study video you've ever had in your life. All right, so this is for your components exam, and when you actually come in to do your components exam, our job as instructors is to not tell you anything, okay? You have to identify everything that is on your checklist. So pull up your progress check components exam 4.5. And one of the first things it talks about is safety. So we're going to ask you general safety questions, or you will need to discuss general safety procedures. So for example, in Price, one of the phrases that I focus on is keep it clean, keep it organized, keep it safe. So we have everything clean and organized here. We are going to pay special attention to leads, battery connectors, where wires are. We have nothing sharp, we have nothing hot. We're not going to turn anything on and have motors or propellers spinning around. One of the other things that you have to demonstrate is just basic flight principles and basic flight inputs. So, for example, you need to know that pitches forward, that pitches backward, that rolls right, that rolls left. On the other side, throttle up, throttle down, yaw left, yaw right, trim button for yaw, trim button for throttle, trim button for pitch, trim button for roll. Okay, kind of the basics of an actual transmitter. You need to know that wings generate lift, okay, through different air pressure systems that move up and over the wings, as well as sucking from the top of the wing. You need to know that this that moves is a control surface. That is an aileron control surface. You need to be able to identify that. This is an elevator control surface. You need to be able to identify that. This is a rudder control surface. Need to be able to identify that. Pusher propeller. Underneath here, you have your control horn that is positioned on the control surface. You have a control rod that is connected to your control horn. The rod goes to the servo. This black thing right here is a servo. This white part is a servo arm. This is a linkage stopper. These things move together when you turn the transmitter on in order to control your rudder. You have additional servo setups for your aileron. Again, control horn connects to the control surface so that the control rod can connect via a linkage stopper to the servo arm connected to the servo. And the way all these work together is through leads, which is going to be on the inside of the aircraft. Something like that is a lead. A lead extension makes, for example, your aileron leads long enough to go all the way through the wing. So when you get down here, inside the fuselage, all of your leads plug in to your receiver. Okay, that is a receiver. Each lead goes into a very specific channel. You know which channel does what by reading the manufacturer's guide. Antennas, you want to be 90 degrees apart from one another. And again, that is your receiver. Your leads go into your receiver. There is always a part on the receiver that tells you positive, negative, and ground or signal channel. And it'll tell you which direction you need to plug your servo leads into the receiver. This is an ESC, electronic speed controller. It connects both to your battery and actually has wires that come through here to connect to your motor. To change the motor direction, all you have to do is unplug 2 of these wires and switch them. It doesn't matter which 2. That changes the polarity of your motor. Now the reason that all matters is because this is an example of a brushless motor. You can see the windings in there. And if we were to open this up, you could actually see the magnets themselves, the stators, and then this is the bell that covers those. So a brushless motor is run by magnets. A brushed motor is run by gears. A servo is a good example of a brushed motor that has gears instead of magnets that run it. We can jump over here to our quadcopter, and we have the same thing. We have a receiver, a lead, but then we also have a flight controller itself instead, or a power distribution board, or a 4-in-1 ESC controller, any of the above. And we have an electronic speed controller for every single motor. So we have 4 of those. Our motors here are also examples of brushless motors. They do not have gears. They have magnets. And our insides basically are a little more complex on a multi-rotor than on a fixed wing. Each of them uses a LiPo battery, lithium polymer. You can see the connector here. That is an XT60 connector, also an XT60 connector. You want to make sure that this connector matches with this connector and not shove different connectors into each other. You have your positive and negative leads. Negative is always black. You want to make sure that you match black to black, red to red. For example, if I were to try to plug this in and have my black wire and red wire crisscrossed, so if I had that and tried to plug it in where black and red are together, I could short out my ESC and cause a fire. This specific LiPo battery is 2.2 amps or 2200 milliamps. You have your milliamp rating there, and this one happens to also have the amp rating right here. Milli means 1,000, so a 2.2 amp is a 2200 milliamp. A 3 amp is a 3000 milliamp. A 5.5 amp is a 5500 milliamp. This has a discharge rate of 25C. Our voltage for 3-cell is 11.1 volts. That is our nominal voltage. Each cell is a 3.7 nominal voltage. This is a 3-cell battery that is connected in a series. It'll say 3S on a lot of the different batteries. The 3 is for the number of cells. The S is for series. When we're charging a battery like this one, specifically this one, in fact, you wouldn't want to charge at more than 2.2 amps on your battery charger. Also on your battery charger, you would want to make sure and plug in the balance lead. That's what this guy is, so that each of your 3 cells in here balances out properly. And that is pretty much what you need to be able to talk about on this exam.